at how to tell which axis our patient is going towards. Like, I mean, axis deviations. So this is an easy method. First method is the quadrant method, and then the next method is the axis method right here. So first up, we will use the method 1, which is a quadrant method. It's very easy. All we have to do is to just compare lead 1 and AVF. And so lead 1, we should just tell if it's positive or negative. This one is more negative. So as you can tell, it's more negative than positive. A positive deflection is like this, a negative deflection like that. And the reason why it's a positive deflection is because the electricity is going towards the lead. And the reason why this is a negative deflection is because the electricity is going away from the lead. So usually you see a pathologic negative deflection in cases of ectopies. So again, let's begin. So lead 1 is more negative. So since it's more negative, it's either this or this. So now we're gonna look at lead AVF. So AVF here is this, and it's a positive deflection, so it's here. So since it's a negative and a positive, then we have a right axis deviation. Okay, now, so this one is saying that it's from positive 90 to 180. So on our axis, you can see that this is 90 to 180. So it's anywhere between here. However, we can specifically tell where exactly on this pie or part of the right axis, and be more precise if we use the axis method. And the way for us to read or know that is by looking first at the isoelectric line. So on our 12 lead, you need to compare what is more closer to the isoelectric line, which is the flat line. So this is the flat line, and the most closest to the flat line is AVR. So like, you cannot use, or we don't use the precordial leads, take note, because we're just using the limb leads for this purpose of knowing the axis deviation. So for us, the isoelectric line is AVR. So AVR is right here. So that's our isoelectric line. Let's mark it. And now next step is find where is the perpendicular line. So that is lead 3. So look at lead 3. Is it positively deflected? Yes, it is positively deflected. So we use 120 since it's positive. If it's negative, then we use negative 60, but it's positive, so we go here. So it's 120. If you want to be even more precise, you can actually compare and look which one is the next most positive lead. So in here, in our 12 lead, the next most positive lead is actually AVF. So this is AVF. So now it can be that it's more like right here. Our deviation. And the reason why I put it like this is because see how positive its positive deflection is? It was not as tall as the lead 3. So it means that it's more closer to lead 3. So it's more closer to lead 3. That's why I put it here. So around this area is where our right axis deviation is. So we got more precise. So, and that's how you read